Hi there, Mr. LaBeouf again. This video is specifically for my 8th grade Algebra 1 students. We're going to consider a quadratic function and its graph. We're going to learn several things algebraically about the graph of this function. The first thing we'll notice is that the graph of this function obviously crosses the y-axis at -12. And the reason for that is that on the y-axis, x is 0. So we simply have to evaluate the function for 0 to find the y value that goes along with it. And symbolically, that would be f of 0 equals 0 squared minus 4 times 0 minus 12. Now, this work is entirely unnecessary because when x is 0, these two terms go away and the y-intercept is staring you in the face. It's -12. The graph of this function crosses the y-axis at the point 0, -12. It's a much more sophisticated question to ask, where does the graph cross the x-axis? And really this goes to the heart of studying quadratic functions. And the discriminant is something that we'll have to learn about in the future. The various ways that the graph of a quadratic function could intersect with the x-axis or not. It depends on the discriminant, which we'll study later. But for now, I happen to know that the graph of this function crosses the x-axis at two places. So I'm going to insert those two zeros in for y on the t-table. And if we want to find the values of x that will make the function equal to 0, set the function equal to 0 and solve for x. And the function is y. Put a 0 in for y and solve for x. And what I've just done by substituting 0 for y is I've written what's known as a quadratic equation. We started with a quadratic function. When we set the function equal to 0, we have what's known as a quadratic equation. And when you solve a quadratic equation, it's important to understand your goal. Your goal is to find the x-intercepts. If they exist, is there one? Is there two? But again, this one has two. I've started with a quadratic function whose trinomial can be factored. This is the simplest way to solve a quadratic equation, is to factor the polynomial, to factor the trinomial. Whenever students study quadratic functions, they've always learned how to factor trinomials first, and now we put that skill to use. This trinomial factors as x minus 6 times x plus 2. And it's a very powerful thing that we've just done, and it's important to realize this. We've represented the trinomial as the product of two numbers, x minus 6 and x plus 2. Well, two numbers multiplying to 0. It's a really simple situation. Any third grader can tell you that that can only happen if one of these, or both, but if one of these numbers is 0. That's the only way that two numbers can multiply to 0. This number here, the x minus 6, will be 0 when x is 6. And this x plus 2 will be 0 when x is -2. So either one of those numbers work. And it's a little bit strange for students the first time through. You spend a lot of time working on getting your signs right in your factorization, but then in this context, you end up taking the reverse of those signs. But it makes perfect sense if you think about what it is that you're doing. Technically, you could say that what we're doing is we're setting each factor equal to 0 and solving. This can be done mentally, of course. But there it is. So when x is 6, the function is equal to 0. And when x is -2, the function is also equal to 0. The next thing we're going to do is find the vertex of the graph. Now, the graph of any quadratic function is a parabola. And a parabola is symmetric or symmetrical around the key point known as the vertex. Parabolas can open up, they can open down, They can be of various widths, but no matter what parabola you have, there'll be that key point there known as the vertex. And the vertex establishes the symmetry of the graph. If we were to imagine a vertical line going through the vertex, we can imagine folding, if the graph were a piece of paper, fold the piece of paper along the dashed line. The right side of the parabola and the left side of the parabola would fall point for point on top of each other. And so because of that symmetry, we can realize that our graph crosses the x-axis at -2 and 6. I won't bother with the y-axis right now, but we know the graph crosses these 2 points. So in order to have that symmetry, the vertex has to be halfway between. The vertex has to be somewhere along this vertical line, that dashed line, that's halfway between 6 and -2. Of course, the number that's halfway between 6 and -2 is just the average of those 2 numbers, which is 2. We add these 2 numbers together, divide by 2, and we get 2. So the vertex has an x-coordinate of 2. And then we ask, what is the y-coordinate of the vertex? And that's easy. The way a function works, if you have a value of x, you plug it in to the function. You evaluate the function for that particular value of x to get the corresponding y. So finding f of 2, we get 2 squared minus 4 times 2 minus 12. That's 4 minus 8 minus 12, or -16. So the vertex of this graph is at the point 2, -16. This is a quickly drawn and very terrible x and y coordinate plane right here. And the graph is probably not going to be very, very good either. But you've got one in front of you. Or you can use Desmos.com to get a beautiful picture of this graph. And please do that in order to confirm what we found algebraically. Well, we started with the Y-intercept at 0, -12. That's that point there. And then we found the 2 X-intercepts at 6 and -2. 6, 0 is there, -2, 0 is there. And after finding those 2 X-intercepts, because of the symmetry, we found the vertex, which is at the point 2, -16. 2, -16 is about there. And I'll put in that line of symmetry like I did before. The line of symmetry is, it's not part of the graph, but it's a vertical line that goes through the vertex. Since the vertex is at 2, -16, the equation of this dashed line, this line of symmetry, is x equals 2. Recall that vertical lines have the form x equals a number. And at this point, the algebra textbooks tell you to do something that's kind of hard to do, and that is to take the points that you have, the points that you've plotted, and connect them with a smooth curve. We could take the time to find even more points, maybe a few more over here, maybe even go up here. Just choose values of x and get the corresponding y, and that would help us to better make that smooth curve. But let me give it a try. Notice the arrows. The graph goes infinitely up, and it also goes infinitely left and right. But that's about what I had in mind for a start anyway on quadratic functions and their graph. So see you next time.